Did you guys like that? Was that good?
That was good.
Is that good? Okay. Yeah, I'm doing a lot more of that in Algebra 1, and certainly open to it in here as well, and we'll just see how it all goes. So here's what I wanted to do. Wanted to leave you with this one. I wanted to work through this one with you. We'll practice this again tomorrow. Our one and only example today says, find the area of the region bounded by the graphs of, so x equals 0 is the y-axis. So there's one boundary. There's the x-axis right there. Anybody not have their packet printed out? Look behind you, Jackson, Tyler. Oh, goodness, what is wrong with the people on the left side of the room? Jed, there's one over there for you, too. Right behind Tyler. We should have enough. Okay, so here we go. X equals 0 is the y-axis. There's one boundary. X equals 1 is over here somewhere. Y equals negative x is right about there. And then y equals x squared plus 2 is a parabola shifted up 2. So we're going to say that that looks something like that. So first of all, can you see the region that I'm talking about? Bounded by all those? I'll color it in here in blue. Trying to find the area of that region between those two curves. And I'm going to sketch in what we call a representative rectangle. That kind of goes back to those rectangles that we looked at. Let's see if this one shows up well. Do you see that yellow one okay? Mm-hmm. Representative rectangle showing up there okay? All right, so here's what we do. It really is a pretty simple process. We would say area equals the integral of base times height. Isn't that what you were doing in your little Desmos activity? Looking at a lot of rectangles, right? Even when you were counting up squares and doing trapezoids, we're really looking at rectangles. So let's keep going. When I look at that representative rectangle, the yellow one up there, what's the base length? Wouldn't that be kind of like the width? How wide would that be if we wanted the exact area? Not like we'd want the width to approach what number? No, if the width approached infinity, it would be like this. We want it to approach 0. We want the number of rectangles to approach infinity, right? But we want the width of each rectangle to approach 0. Here's how we do that. I'm going to say the base length. I'm just going to call it dx. Dx representing a really super tiny little change in x. And that is my base length. And then my height. And this is really the key thing. Say again?
It's the distance between the two functions.
And how do you find the distance between two things? You subtract high minus low. So, in this case, the high function is x squared minus 2. X squared plus 2. And then we subtract the lower function. So it'd be x squared plus 2 minus negative x. The final thing I need to put in here is my interval over which I'm accumulating all this area. So where would I start accumulating? When x is 0, right? That's the left boundary. And where would I stop accumulating area? Isn't that the right boundary over here? So I would stop at 1, and I'd have all these representative rectangles in here potentially. And I would stop accumulating once I bump up against that right boundary. So how do you evaluate this? Well, I think the easiest way is either with your calculator if it's active or fundamental theorem of calculus, right? So it'd be integral from 0 to 1. It would be x squared plus x plus 2. What do I need to do next?
Integrate.
Yep, get an antiderivative. So it'd be 1/3 x cubed plus 1/2 x squared plus 2x. Evaluated from 0 to 1. So it's kind of lovely that there's a 0 in there for the lower limit, because all I have to do is plug in the 1. So it's going to be 1/3 times 1 plus 1/2 times 1 plus 2 minus 0. So what is that? 5/6 plus 17/6? 17/6 sounds about right. So I'll squeeze that in right on the edge there. 17/6. Who would have thought that that would be the area? There you go. This feels like we should probably practice this for at least one more day, right? So we will do that tomorrow. We'll get some more practice with area then. But for now, if you guys would build a fort, we're going to do some differential equations on your quiz here.
Is there a calculator on this quiz?
I don't remember. Why don't I look? No calculator. You didn't bring yours? Worked out just fine then.